Hey everyone, today we're going to talk about average and instantaneous acceleration. So to start us off, what is acceleration? Acceleration is defined by the change in velocity over the change in time, which, as a callback from our last lesson, the velocity is referred to as the change in displacement over the change in time. Or more of the change in position, which is equivalent to displacement. Now then, to see this in a better fashion, let's create a velocity time graph. Now then, on this graph, I would have some random curve, and this represents velocity, and this represents time. I wanted to find the average acceleration between some time t1 and some time t2, which would have a velocity of v1 and a velocity of v2. It will be the same as finding the slope of the silicon line that is between these 2 points. Now then, this line is defined by rise over run, or the change in velocity over the change in time. So, some knowledge we need to know about acceleration is that acceleration is equivalent to length over time squared. That's the units for it. And you can see this in meters per second squared. You can see this in kilometers per hour squared. And overall, it makes logical sense as you find the velocity by doing the change in position, which we can define by length, over the change in time. And if you were to divide that divided by time, it'll be the same as multiplying it by 1 over time units, which would lead me to a length over time squared unit. So now that we understand the units for acceleration, let me clear up a common misconception a lot of people make when first thinking of acceleration. Is a lot of people think, oh, velocity is positive, acceleration is positive, vice versa. This is entirely false. And I like to think of it as this way: acceleration or velocity is the rate at which position changes. So it's basically how fast position changes. Acceleration is the rate at which velocity changes. So, for example, velocity could be going from some person, I'm walking at a speed of 3 meters per second, I can go down to 2 meters per second. And let's say this were to take 5 seconds. I would end up having an acceleration over those 5 seconds of 2 meters per second minus 3 meters per second over 5 seconds, which would give me a negative 1 over 5 meters per second squared acceleration. Now then, here the acceleration is negative. However, the 2 is greater than 0 and 3 is greater than 0. Therefore, we can say that the velocity at both points is positive. Now then, now that we have, we understand average acceleration, let's talk about instantaneous acceleration. So, the definition of instantaneous acceleration is the limit as the change in time approaches 0 of the change in velocity over the change in time, which we can call dv, a very small velocity over a very small time. Because as time approaches 0, both the changes will be extremely minimal. So then, let's say I have a velocity time graph again, like this, and I want to find the instantaneous acceleration at this point, right here. What I would end up doing is finding the tangent line to that point. Because if you look at the definition of this, when time approaches zero, and as we defined previously, it's the secant line between the 2 points. So as time approaches zero, or the change in time approaches zero, that means there would only be one time point. So therefore, what was before the secant line has to become a tangent line, as it will only meet the time point once, as there is only one time point, since the change in time is zero. Right? And based on this, since it is always going to be the tangent, and this is true for every point on the graph, we can actually confirm our dv by dt statement, not just as a small v over a small t, but rather a derivative statement. So therefore, dv by dt as a derivative is equivalent to the acceleration. So let's take an example. Let's say I were to have someone's velocity modeled by t squared minus 2t plus 4, and I wanted to find, or rather, someone's position. If I wanted to find the acceleration of this, how would I do so? First, I would differentiate this once, dx by dt, to return me 2t minus 2, and this is equivalent to the velocity. And I'll differentiate it again, d2x over dt2, which will give me an acceleration of 2. So yeah, that's how you find an instantaneous acceleration. And that's generally how average and instantaneous acceleration works. Hope this is helpful. Have a great day.